Hello everyone, I'm Michal and I will be explaining a solution to problem J, a split stream. So this is a problem about gates. We have two types of gates, a split gate and a merge gate. These gates are processing sequences of integers. For the split gate, if you have a sequence that is coming in, then it is alternately sent to the left and the right output. So you have a sequence that is 1, 2, 3, 4, and so on. Then 1 goes left, 2 goes right, 3 goes left, 4 goes right, and so on. The merge gate is the exact opposite. So we have two input streams and one output stream. What it's doing is merging the input streams in the order left and right alternately until it runs out of one of them. And when it runs out of one of the streams, then it just continues taking elements from the other one. All of these sequences are finite, so eventually they will run out. What we are given in the input is a description of an entire network of such gates. We are starting with a single input, and the input is plugged into a split gate, and there can be multiple other gates connected, and so on. And onto the input stream, there is a sequence of up to 10 to the 9 elements that is entering the entire system. Now, the entire system can have up to 10 to the 4 nodes, and now we are given a collection of 10 to the 3 queries. In each of the queries, we are given one specific wire in the network, and we are given an index, k, and we are asked what is the value of the kth element that is traveling along this particular wire in the network. So how can we answer such queries? The tricky part is what happens with merging when we are merging sequences of unequal lengths, because if everything were infinite, then it would be very easy. If you are splitting according to parity, and when you are merging again, you know that the odd-numbered elements are coming from the left and the even-numbered elements are coming from the right. But if the sequences are finite, they can have different lengths, then you can have more complicated situations. And the answer to this is that you can determine everything you need as long as you know what is the size of each of these streams. So we can start at the very top of the network and go from the top to the bottom, and for each of the out of the wires in the network, we can compute the number of elements that reach this wire. So whenever we have a split, then half rounded up goes left, half rounded out goes right. Whenever we have a merge, then it's the sum of the sizes of the two input streams. And now when we know these sizes, we can answer each query by doing the exact opposite, by going up the network. So now we can enter a gate, and when we know the sizes of the, so if it is a split gate, we know how to merge those two incoming streams back into the first. So what we can do is we can recompute the new index in the previous stream, and this way we can propagate it all the way to the top. The last reminder about this problem is we just need to be careful about the implementation. So for example, if we are given the number n of gates in the network, you have to realize that the number of wires in the network can be up to roughly 2 times n, not just n. And also you need to be careful not to overflow in the situations where you are given an index of an element that doesn't exist. So there can be queries where the answer is none, there is no such element, and you need to handle those carefully. And that's it about this problem.
For more from the ICPC World Finals Dhaka, follow us at news.icpc.global and on social media with our hashtag ICPCWFDhaka.